we're continuing with the overview. We finished a couple lines of it. What else do we need to know here? We have our first differences. It's linear. Second difference is the same. It's quadratic. What else do we need to know about a function? Anything else you guys want to add to it? No? Okay. How about we add transformations now? I'm just going to extend characteristics because it tends to be a pretty big slot. Okay? What about transformations? Does anyone remember our model equation? What the model equation is going to look like? We write it in function notation. It's got 3 different letters we're not used to seeing. Jordan? Yes. So our parabolas, our quadratic equations were written like this. F at x is equal to a minus h. I don't think those are the colors I used before, but plus k. Good. So that's our function notation for a quadratic equation. Make sure you know this for the test. You have to know this. Okay? If you don't, learn it right now. Morning, Stuart. Let's talk about what A does, what H does, and what K does. Okay? Who can tell me, we'll start with the easier ones. Who can tell me what K does? Thomas.
If positive, it goes up, and if negative, it goes down.
Beautiful. So, I'll do it in blue because K is blue. If K positive, function moves up. And if K negative, we'll write K in there so it's a better note that way. If K negative, function moves down. That makes sense. K is positive, goes up. Negative, we transform the function downwards. How about H? Who can tell me about H? What's that, Matthew? That's right. So our H is the opposite of K. If H, that's not how you spell it. If H is positive, the function moves left. And if H is negative, function moves to the right. Okay? In case you don't know your left and right. There you go. Finally, A. We're going to do 2 separate notes for A. First one, I want to know if A is a positive number, what's going to happen? And if A is negative, Joel? Yeah. So, if A is positive, our parabola opens up, we'll say. And Joel, what happens if it's negative? That's right. So if A is negative, parabola opens downwards. Now there's 2 other things I'm going to need from A also. You know. Okay, so when does it stretch and when is it compressed, the parabola? Yes. Good. So if A is greater than, we're going to use greater than sign, 1, parabola is stretched. And if, now this is where we get used to our double restriction again, okay? If A is greater than 0 and less than 1, we have a double restriction there. Just like we were just doing with our domain and range, double restriction. It's between 0 and 1, the parabola is compressed. Parabola is compressed. Very good. So that essentially deals with all of our ideas with A, H, and K. Any other characteristics you guys want to add to this for your notes? These are your notes. If a function, I'm going to ask you one other one, okay? We'll say it's a continuous line, and I have to write it in, I have to write domain and range in the style we've been using. How do I represent a function that is a continuous line? How do I start writing the domain and range? We just did it, like probably 8 minutes ago. How would I start it? I would have my domain, then that funny looking bracket. What are those 3 letters I use? Thomas.
For X, and then take real numbers, take E and R.
That's right. Okay, so just make sure we know this last one. For domain and range. So, if a function is a continuous line, we start domain and range with, and this is the important part, either X, all real numbers, or Y is all real numbers. Actually, more importantly, which we didn't touch on, what does domain mean, or what does it refer to, and what does range refer to? John? Yes. Domain, x-axis, yep, and range, give me 1 second, equals y-axis. Okay? Okay, we're going to continue with some examples here, guys. I'm going to need an example of something that is a function, and because we have non-examples, I'm going to want something that is not a function also. I want it on a graph, let's say. A circle would be what, Tom? Not a function. So, we'll split this in half. Non-examples. Okay? Example of a function. We'll just draw a straight line. This is our vertical line test. Okay, so we drew an example of a function, vertical line test. It passes at every point, so we know this is a function. Tom gave us an example of a non-function. Circle on the graph. When I draw the vertical line test, it touches the line or the function twice, which means this is not a function. Okay? So we have an example of a function and a non-function. You guys okay with that one? Okay, we drew vertical line test. That was one of our ways of telling. Let's do example of a K movement. We'll do quickly a K movement. So put it under examples here. Say we have a graph. Our normal parabola touches like that. This is, we'll say K is positive. Okay? K is positive. Parabola moves up. K negative. That's just a quick note. So our black one is our original. If K is positive, we move it up. If K is negative, we move the parabola down. Left and right. Okay. to the right, to the left. We move it to the right if h is negative, and if h is positive, we move it to the left. Okay? These are examples of some of the notes we made under characteristics. So we're just trying to get some visuals of it. And finally, let's do our final two for A. We'll say this is our normal function. Actually, we'll do both in red. Our top one is when A is positive and when A is negative. Okay? A is positive, opens upwards. A negative, opens downwards. Let's draw our original. Here's a stretched version of it. Here's a compressed version of it. Looks much wider. The stretched version is when A is greater than 1, and the compressed version is when A is greater than 0, but less than 1. So these are all examples of some of the notes we already made. You guys can make non-examples of these. It's up to you how you do it. The only non-example I think we really need is our vertical line test. We have examples of KHA. Oh. We're going to do one example of function notation. Yeah. Is that good?